This is example 2 from the old stuff review for the final exam, which would be exam 1 through exam 3 material. So these are the most important word problems, and one thing you're going to have to do is identify what type of word problem this is. So let's go ahead with example 2. All edges of a cube are expanding at a rate of 3 centimeters per second. How fast is the surface area changing when each edge is 10 centimeters? So I'm going to draw a little picture here to start out that I have a cube. So I will be labeling some stuff on there. An important thing is what the question is. That's going to tell me what type of problem this is and how to approach it. How fast is the surface area changing when each edge is 10 centimeters? So notice what's being asked for is a rate, because you're asked how fast. And it's asking for the rate at which the surface area is changing. And so what I'm trying to find here is a derivative. So we can translate a rate being asked, or how fast is something, as a derivative with respect to time, and this derivative here is the surface area. I'm just going to call it A instead of SA so that it doesn't look like two variables or something. So I'm going to find dA over dt when, and then instead of given a time, we're given when the dimension is something. So each edge, so I'll define that as x here quickly, is 10, and since it's a cube, every single dimension on this is x. So moving forward from there, we don't know for sure what the formula is that we're going to use. Sometimes it's not really obvious. In this case, it actually is kind of obvious because I'm trying to relate the things that I am either trying to find a rate or I'm given a rate for. So I need an equation, and it needs to have an A in it for surface area, so strip down of the rate part. And then I'm also given a rate, so it says that each of the edges are expanding at a rate of 3 centimeters per second. So given that I'm calling each dimension x, this is going to be dx over dt is 3 centimeters per second. So it also has to have an x in it. So given that part, an equation with a and x in it is going to be the surface area equation of the cube. So this formula is not given, but we can derive it quite easily. Notice that each face is going to have area of x squared. And so all we need to do here to find this equation is to add up all the faces. So I have the front face, I have a face here, which probably x is a little confusing, so let me erase that. So I have one face here, face here, face here, that's 3, one in the back 4, the other one on the other side 5, and the bottom, which is 6. So this is going to be 6 times x squared. So now I have everything I need to go ahead and take the derivative, because when I take the derivative of both sides with respect to t, what's going to be produced is a dA over dt with maybe some byproducts, and a dx over dt with maybe some byproducts, and I have each of those things accounted for. I'm trying to find dA over dt. I'm given dx over dt, so I'm ready to go ahead and take the derivative. So remember this step, this is 3.9, is taking the derivative implicitly on each side with respect to t. So here's a step saying, hey, I'm going to do this. Now I'm going to do it. So the derivative of a with respect to t is just dA over dt. And then here I have a constant 6, and I need to now use like what the chain rule is, because x is implicitly a function of time. It's changing with time, but I don't have x explicitly as a function of t. So I use implicit differentiation, where I take the derivative with respect to x, or the outside function. So that's just going to be 2x where the original inside function is x, and then the derivative of the outside function, use the chain rule, is dx over dt. So now we're supposed to find dA over dt, so the fact that we have a variable thing for that is good. And then x, we're supposed to do this when x is 10, and we're given the rate dx over dt. So this worked out really nice. I can plug stuff in and solve. So dA over dt, and then I'm going to have 12 times 10 times 3. So just finishing that out, I get 360. You don't have to put the units, but what the units would be here is area over time where the original units were given in terms of feet. We're just kidding, centimeters. Shouldn't even label stuff, let's see here. Yeah, centimeters. Centimeters squared per second. And that's it.